Okay, so exciting times at ECL. I think I spoke to someone back in June. You'd announced a revolutionary off-grid, sustainable, and modular data center solution. So just remind us about that, and then we can talk about the, shall we say, even more or equally exciting news that we're going to chat about today.
Sounds good. Yes, we announced our first site up and running in June. The site is delivering the first fully off-grid hydrogen-based data center, which is zero emission and zero water on site. The solution right now in our headquarters in Mountain View is the production solution that will be repeated with the modular way. And the capability of modular way is very important nowadays. It means that we're building 1 megawatt blocks and we repeat them as many times as we need for larger sites. And when we do that, we deliver two things. One, we deliver fast time to delivery to the customer from PO to key. But the second thing is we're tracking the evolution of technology, and that's very important. The AI technology right now is evolving on a 9 to 12 month cycle, and the data center build outs traditionally is 3 to 4 years cycle. So if you start building a data center right now, in 4 years, you get a data center which does not match the technology. We are modifying the blocks of our modular solution on the fly. So the first 50 blocks will accommodate today's technology. The next 100 will be accommodating next year's technology and forth and moving forward like that. Our customers love it because from their perspective, they have a protection of their technology. They can stay with the cutting edge of the technology, but don't have to pre-commit to what will happen in 4 years that nobody can actually guess today what will happen in 4 years.
Yeah, and bear in mind what we're now going to talk about. That's particularly relevant because I think you have announced or you're committing to building a 1 gigawatt
Yes.
AI factory data center, as you term it.
Yep.
I think it's in Houston, isn't it, in Texas? So it'd just be good to understand a little bit of the background to this announcement.
So the announcement came after analyzing the market and understanding that the need right now is for large-scale environments to address LLM needs. It will continue to go that way probably for the next 45 years, but in within 2 to 3 years, we're going to start seeing more and more inference, smaller sites next to the endpoints. But right now, the need is to deliver very large-scale environments. And as a result, we decided to actually take this step and actually move to a 1 gig site, which is representative of what's expected to be in an LLM environment. We picked Houston because there is a significant supply of hydrogen in Houston from multiple suppliers. So we can deliver a reliable data center at 1 gigawatt capacity that will be delivered to our customers starting next summer and then continuing with multi-phase every 6 months. So we will probably complete the 1 gigawatt site within 3 years, and then we'll actually deliver multiple customers environment. Our site over there is going to be sectioned into sections per customer. Each customer gets what's called a private colocation. So it's a colocation because the campus itself will have multiple tenants in it, but each tenant has its own section, which is independent. That site is representative of how we do the modularity. So that's exactly how we actually take the block, which has been proven, the technology has been proven at our Mountain View site, and then we just replicate it. And just to quote Intel, copy exactly. So we just copy it and just repeat it again and again and again. And because of that, we can actually accelerate the process to deliver the data center as well, because we can build in parallel. It's not one big structure that we're building 100 structures, small structures, but with 100 of them. And it also be the first place we're going to demonstrate our capability of leveraging 3D printing for the site. So we will print the site over there with a 3D printer from concrete and deliver a solution which is high reliability and really cutting edge of the technology. That site initially will have 75 kW per rack with expected PUE in that area because of the temperature and humidity of about 1.1, which is very a strong level of efficiency. The important thing to mention about that site is that that site enabled us to actually demonstrate capability to deliver data centers which are on the cutting edge of need of AI without a premium that is going to be required from the customer. We can deliver electricity at a price which is very competitive. We can deliver rent and efficiency levels which are very competitive in this market nowadays. And as a result, the view of sustainable data center is some kind of a dream in the future is actually completely now dissolved. It's real, it's now, it's here, and it's starting in Houston, Texas, but it's actually going to spread towards other locations in the United States and Europe as well.
Okay, and if I've done my maths right, is it 100 megawatts is the first build, or what are you
That's
building
the
out
first phase. Yeah,
that's the first
first
phase.
phase,
And
100
you
meg.
say over 3 years, so every sort of what, 6 months, well, probably 6 months or under, you're going to add another block till you get to where you need to
Yes.
be. Is that right? Yeah.
Exactly. So every 6 months, we depends on demand. We will add an additional 100 to 150 megawatts. So we want to complete the whole site within about 5 to 6 cycles of 100, 150. And we don't build more in the first phases exactly for the reason I explained, that we want to maintain the ability to change the block when we move forward. But based on demand, if the customer wants us to actually run faster, we will run faster. We can run very fast on building those sites. But if the customer wants to pace it with the technology evolution, we'll pace it with the technology evolution.
And if I understand as well, you're clearly building out the high density space for the AI itself, the hardware, but I think you're also building out space for tenants, their sort of ecosystems, the partners, and anyone else. So if you can just sort of detail that, that would be great.
So we announced in the announcement our initial partner, which is Lambda, one of the cloud AI operators. But we have already significant high level of interest by other customers that will take sections. And each when we say we're going to build 100 meg, potentially it's going to be 2 or 3 customers that will take each and every one of them will take a few tens of megs. And then we're going to continue to evolve each one of the sections for each one of them independently. So each one of them will get the ability to grow at their own pace. The beauty of what we're offering to our customers, it's built to order. We will not build for you anything until you're ready. So you're ready, you give us a PO, 6 months later, you get the section that you want. If it's a 10 meg, 20 meg, or 50 meg, or 100 meg that you want in that section, that's a 6 month cycle. That creates for the customers a tremendous impact to their planning cycles. Traditionally, when you build data centers and plan to fill them up, you have to plan about 3 years out. So you have to allocate the space 3 years out, and you have to plan what's in there. So you define the specs for that. We are changing that. The cycle right now is 6 months. You can actually run your planning cycle, decide what you need for the next 6 months, put a PO, and you get the access to the data center after 6 months. Then start another cycle of 6 months. And that's continuously operating. Now, that is with a data center, which is really one of the highest end data centers in the world today. And it's addressing probably the biggest challenge that we have right now with building data center is where do we get the power? There's a very significant shortage of power in our industry today. We expected to build tens of gigawatts in the coming years, and there is no viable way to get those tens of gigawatts from the grids. The grids are just not available. Now, the secondary thing for that is creating energy which is fully sustainable, zero emission. The grids today are dirty, and they will not be cleaned up for a very long time. And we are offering not only the availability of the power, but the availability of clean power, which is a huge step in the data center world to be able to actually accommodate green data centers, fully sustainable data centers, not by buying credits, but by actually building it green.
And to further on to what you've discussed there, do you think the data center industry in general, whether it has an obligation or it's the way it's got to go, as you say, there's not enough capacity on the grid to plug into? So do you think it's a sort of obligation, or at least it makes business sense for data centers to understand that off grid is the way forward, and then maybe at some stage their off-grid offering, they can plug it into the grid at a later stage, and whether it's they feed power back in, or at least give it back to the utility, but for now at least off-grid is a great way forward.
Yeah, I think the challenge we're seeing is that the cycle, so we talked about the cycle of technology and cycle of data centers. The cycle of the utility is even slower than the cycle of data centers. So they're talking about 5 to 10 year cycles to actually build infrastructure, transmission, generation, etc. I think there's a very strong commitment from the data center builders to actually build fast and build clean and support the grid. We don't have anything against the grid. We will support the grid when the grid is going to be available for us. But for now, until the grid is actually going to be available, all the data center operators are looking for alternatives. If there talks about SMRs, small nuclear plants, larger nuclear plants, commitment to use of higher level of renewable energy, etc. So the data center operators are looking for any way they can get power right now, because what's happening with AI is AI has a window of about 4 to 5 years that we need to accommodate what's required for it. We don't have 10 years to wait for a new power plants to come online, etc. So in the long run, definitely we want to be a good citizen on the grid and deliver and help to support the grid, because the grid is supporting the communities we live in. But in the short term, the best citizen on the grid is off the grid. So don't load the grid. So then you're the best citizen on the grid. When the grid is ready to actually take you in, you can connect to the grid. There's nothing prevents from any of those off-grid data center, which are running microgrids right now, to connect to the grid, either as a consumer or as actually a producer of energy.
And in terms of hydrogen as a power source, is the US sort of uniquely placed with plentiful green hydrogen available, or can you see it, being developed elsewhere across the world? And I guess also to your point, if AI's got this window, will
Mhm.
hydrogen, be available plentifully, shall we say, in other regions outside of the US?
Yeah, so the US is uniquely positioned from capabilities to deliver high capacity hydrogen through a pipeline. That's what makes it special. Now, it's not necessarily green hydrogen. There is not enough green hydrogen in the world today to deliver what we need for data centers. So initially, we build the data centers to run on hydrogen, but we are blending different colors of hydrogen, gray, blue, and green. Specifically, we start with a blend of gray and blue. Blue is a carbon captured gray, when you do the blend of gray and blue, you're better than any grid in the United States from a carbon footprint perspective. At year 2, we plan to actually start blending blue and green. We termed a new term called turquoise, and we call it turquoise hydrogen. And the goal for us is to increase the level of the green in the turquoise as much as we can, as soon as there is enough availability. I think a lot of the hydrogen producers in the United States are looking for the off-taker. Who's the off-taker? Now we are representing for them a very large level of off-taking, so to encourage them to actually start building more and more facilities to generate green energy and generate, as a result of that, green hydrogen. So it was a catch-22. Who's going to take my hydrogen? Why should I produce it? Now we are coming and say, we'll take your hydrogen. Initially, we'll take hydrogen, which is blue, which is just carbon captured one. It's still very, very good, but it's not good enough. But now you have the motivation to go and build your green generation, and we'll take that as well. What's happened around the world is, in other places, people are thinking about strategic way to actually deliver hydrogen. In my view, the focus is way too strong on only green hydrogen. There are multiple ways of getting hydrogen. I think France just announced that they found unbelievable white hydrogen, which is naturally occurring in the ground, and they can pull it directly. So I think at this stage, we should not restrict what kind of hydrogen we use. We need to actually act in all the dimensions of hydrogen availability, and then transition as soon as we can to cleaner and cleaner hydrogen, which comes from either sources of renewable energy generation and other sources like the discovery of the white hydrogen. I think the important thing is for delivery of hydrogen, we need to create a pipeline system. And the US is uniquely, especially the area that we're in, operating in Houston, has a unique distribution system of hydrogen through a pipeline. Because when you use large volume of hydrogen, it makes sense to use it if you deliver it in gas state through a pipeline. Just like we have natural gas coming everywhere, we should have hydrogen delivered everywhere. And then you just tap to it in the areas that you want to actually get the access to it. I think the European Union is doing a major project right now, running a pipeline all the way from Morocco to Sweden. And that pipeline will carry very large quantities of hydrogen. I think it's important they will accelerate the process to be able to deliver this as soon as possible. Until that's available, there are other sources of hydrogen in Europe. The reason ECL is saying Europe is a bit behind for us is that it's not completely figured out how we actually create the business model for hydrogen in Europe. In the US, we solved it. We can generate energy at a price which is very competitive. In Europe, there's still work to be done about the availability of how many tons per day we can get of hydrogen and what will be the price of that. I think it's about a year behind the negotiation that we had in the US. So I don't think there's something blocking us from doing it in Europe. It's just a matter of completing the discussions. In Europe, the challenge is actually bigger in some cases because the price of energy is higher. In a lot of places like Germany and other places which are pay very high price for energy, we can come in with the green power, which is coming from our data center. It's a much lower price. So that will accelerate the process in Europe. It's just a matter of establishing the supply chain of hydrogen. For us, it's critical to have multiple supplies of hydrogen because when you're off grid, one of the things that the customers ask is, I need to get reliability in our system. Reliability means I need to get hydrogen at least from 2 suppliers. That's the minimum. In Houston, we actually get from 3 suppliers. So that's the key, and we'll figure it out. We are working towards that. We are hoping that the first deployment in Europe is going to be in the 2026 timeframe, and will enable us to actually start putting our footprint over there, also for large sites and smaller sites.
Okay, and just in terms of other bits related to data center, obviously the hydrogen power supply is pretty much central, but you've also, I think you've got the ECL, you've got the Lightning data center management, and then it'd be good to understand, the cooling, what the cooling solution is. Just anything else you can tell us about, what goes inside one of the modules.
Yeah, so the modules have been designed from scratch. So what does that mean? It is we took a clean slate and said, okay, what's the best data center we can build right now with the technologies that we develop and the technology that already exist. In the cooling system, we created what's called a multi-loop cooling system. So we have 4 loops of cooling systems, which are bringing cold water into the environment in different ways. If it's evaporative coolers, if it's chillers, if it's hydrogen-based cooling, we have multiple patented way of how we do this. Then we blend them together into a single feed into the data center, which is running water. Now, you ask us, where do you get the water from, right? Water is part of sustainability. Luckily for us, and not just luck, actually, we thought about this. When we generate energy with hydrogen, the byproduct is water. So we take that water and cycle it back into the data center. So in reality, we tie together the hydrogen-based power generation with the cooling system on multiple layers. The first layer is actually, we have water. We don't need to take water from the community. The second layer is actually, we use the hydrogen in some cases to actually cool the water. So it's actually supplemental to our cooling system, which is based on multiple layers. Like I said, evaporative coolers, special chillers, etc. Now, what we did with our management system, which is the Lightning system, we're actually collecting about 2,500 test points and measurement points every 5 seconds across the data center for every block. We collect that data right now, and we're going to actually run a full LLM model to teach the model how a data center is supposed to behave. We are going to production next week with fully loaded system. So our customer, the first customer that we have, Cato, is actually coming into our data center next week and going to run full, about 1,800 GPUs will run in our data center in Mountain View. And that will actually enable us to start collecting tremendous amount of data. It's going to take us probably a few weeks to a few months to collect enough data to teach the Lightning system. And then the Lightning system will come back and actually do what's called micro adjustments. The micro adjustments will actually adjust the site in very small cycles. And adjusting the site means adjusting the power system, adjusting the cooling system, adjusting the way we operate every few minutes, which is usually humans cannot do that. It's only an artificial intelligence capable machine that will do, and we will have the data to feed that. Because the data, AI agent is as good as the data you gave him, and as good as how the training was happening. So that's the key for us in the Lightning system. The Lightning system also gives to our customers full visibility of what's happening in the data center. So they don't need to actually worry about what's happening here and look at different tools, etc., both from an operational perspective as well as a customer visibility. So it's a very unique system. We built it because we couldn't find something in the market which was at the level that we were looking for. It's not that we are looking to actually develop more things. We're just looking to build the best data center possible. And we found out that we have to actually develop this system by itself. And we are very happy with what we have right now, and we're even more excited about what's coming for us in the coming months once the AI is going to be fully functional and active in the data center.
And I'm just wondering, clearly you are very busy, and building a 1 gigawatt data center, is going to keep you busy for a wee while. But I'm just wondering, are you also looking at other sort of types of data, providing other market? Clearly the AI one's the one that's here and now and very busy, but what you're doing, does it make sense to just produce for sort of normal data center loads at some stage in the future? Or even if you're modular, you can shrink the technology down for some of these edge applications. People, just, I guess, your thoughts as to where you might take the data center
Yeah.
sort of blueprint that you've developed.
So our market is not necessarily just the AI. We do very high density racks, so we can actually operate very good in an AI environment. But for some customers that actually use more traditional compute, they're asking for a lower power per rack. They don't need the 50 to 75, they need 25 to 30. We use exactly the same modular block, just put more racks in there and reduce the power per rack. We don't need to do anything except that in our technology for generation, for cooling, for anything else. So our target for the blocks is actually dedicated. We do build to suit. So if the customer wants 25 to 30 kilowatts because they're using just standard servers, they will get exactly the same block with 25 to 30 with more racks in there so they can put more servers. With regards to edge, so the edge is moving forward towards a 1 to 5 meg per site, in some cases even 10 meg per site on the edge. It's again a good match for us because at 1 to 10, we actually don't need pipeline delivery to our data center. We can operate on the delivery of liquid hydrogen. It makes the energy a little bit more expensive, not much more expensive, and give us the ability to place the systems anywhere we want. Our Mountain View site is a liquid hydrogen based solution. So it's actually running based on liquid hydrogen with delivery. Up to 10 megawatts, we need a small number of deliveries per week. And the delivery of hydrogen, liquid hydrogen, is a safe environment. It looks like a delivery system of a gasoline station. And it connects after 1 hour. You get a week and a half to 2 weeks of capacity per block. So we're definitely looking at not just the giant sites, also smaller sites.
And I'm just wondering, so I say we talked first, I think in June, and then now, so timing wise, I'm thinking early in the new year, you're going to have something else equally exciting to tell me, or just what's on the roadmap that you can share maybe as to,
Yeah.
the obviously you're building out this, I understand, but just anything else you can share as to future
Yeah,
plans.
we're building the site as an independent project, but in parallel to that, we're continuing to develop our technology, and we are pushing our technology right now to enable the next generation of the GB200s from NVIDIA, which requires about 150 kW per rack. We're developing specialty cooling system for it and specialty power feed into those racks. Those racks are very special and are not simple to solve the problem. So we're developing on the power side, on the cooling side, and the management side, the capability to take those racks into the next phase, which is probably going to be the end of 25 production deployment in high volume. So that's one area that we're actually developing new technology. We're continuing to evolve the lightning system. And we're doing some other things that I cannot talk about at this point, but other things that will actually, again, continuously differentiate the ECL solution for our customers and deliver to our customers always a competitive advantage compared to traditional data centers.
And just on the AI front, as you say at the moment, obviously the large language models, that's what's sort of driving the sector. I say when they've done, presumably they're always going to be getting new data sets, which they have to process, but maybe not as intensively as they are now. So just, I suppose, what's the future when AI it'll never stop it, but how do you see the intensive nature of it, as I say, maybe, calming down and becoming more steady? Just your thoughts, I suppose, as to how it
I think the next 4 to 5 years are going to be probably the years where the LLMs are going to be dominating. And in the tail end of that, we'll start seeing more and more large sites, which are edge sites. We're going to do inference. They're going to overlap, right? Because the models, if you don't use the models for inference, they're useless, right? So you can't really monetize them. So a lot of investment comes in the front end, in my opinion, next 4 to 5 years. And then year 3, you will start seeing significant investment on the inference. If you look at the long run, there's no doubt in anybody's mind that the inference data centers will overshadow the LLM ones from a capacity requirements, but they're going to be highly distributed. So they're going to be in a lot of locations. The edge is on people's minds since a very long time,
Yeah.
for at least 10 plus years, but nobody actually found the actual winning applications. And it seems like the inference for AI might be the winning application to justify the investment in the edge. Because when you do highly distributed edge solutions, you actually requires much higher level of investment because it's many places, smaller sites. So the site prep and the site work is actually multiplied by 10x, 100x, and 1000x in some cases. So I think just to summarize, 4 to 5 years for heavy LLM learning. And then again, we're guessing that that's a situation. We don't know what we will be evolving in the next cycle from an LLM perspective because we have generative AI. These AI agents are actually launching other AI agents, and they actually can get to the point they might need more faster, or they will actually at some point saturate. The inference is the one that we are facing as users. That will be more and more mainstream, in my opinion. We passed the point of no return, basically. So we are going to have heavier and heavier dependency on AI. Not everybody likes it, but it's the reality right now. So we have to accept the reality and move on with it. So I think we're looking for a 10 years cycle, which is going to be very fast. Will everything that we're doing at AI right now going to move forward? I'm not sure. I'm sure they're going to be consolidation at some point, and we're going to start seeing more and more targeted solutions and less general solutions. But that's a matter of the market. We need to let the market actually stabilize independently and not actually try again get involved, because these markets are very large and with huge investment. They have to self-stabilize. If we try to stabilize us from the outside, like government intervention or something like that, it can create major challenges with how we actually build those data centers and how we get the AI to evolve.
Okay. I mean, we covered a lot of ground and some fascinating information there, and it's very exciting. So, Yuval, I really appreciate the time you give me today and all the information. So, thanks very much indeed. Thank you.
Thank you very much. I'm looking forward to actually continuing to have the discussion when things
For
evolve
sure.
every few months. We're operating in a very fast pace right now.
No, thanks again.
Thank you.